For this PAV, we are asked to find the acceleration of a freely moving charge with a magnetic field acting on it. So we are given a charge, an electron, that is moving down with a velocity of 2,000 meters per second and a magnetic field pointing left, which has a value of 2 Teslas. And we know that the mass of an electron is 9.1 times 10 to the negative 31 kilograms, and the charge of an electron is 1.6 times 10 to the negative 19 coulombs. So to solve for this problem, we need an equation that could relate force to velocity and the magnetic field, or just an equation for the force on a freely moving charge. And that equation is the force is equal to the charge with the multiplied by the velocity cross product with the magnetic field. Or we rewrite that as the magnitude of the force is equal to charge times magnitude of velocity times the magnitude of the magnetic field, sine theta velocity magnetic field. So we can see here that the angle between the velocity and the magnetic field is 90 degrees. V points down and B is to the left, and that is a 90-degree angle. So sine 90, which is equal to 1. And now we could just plug everything else in, and we get F is equal to the charge times the velocity, which is 2,000 meters per second, times the magnetic field, which is 2 Teslas. And we said that sine 90 is 1, so we just write that as 1. And we calculate that. 1.6 times 2 is 3.2, times 2 is 6.4, times 10 to the negative 19 plus 3 plus 0, negative 16 newtons. So that's the magnitude of the force. Now to find the acceleration, we relate that to Newton's second law, where force is equal to ma. And we can rewrite this as the magnitude of A is equal to magnitude of F over m. And if we plug in F, which is 6.4 times 10 to the negative 16 over m, which is 9.1 times 10 to the negative 31, we get 7.03 times 10 to the 14 meters per second squared. Now we found the magnitude, but what about the direction? To find the direction, we actually have to use the right-hand rule, where we do a cross product of V and B. So I will draw the vectors again. This is V and that's B, and wherever our thumb points is F. So it's kind of hard to do it this way, so I'm going to actually flip it here. So this is our V vector, right? Now we point our straight fingers in the direction of our v vector and then curl it to our magnetic field, the B. And B is here, so we curl this way, and we see that our thumb points into the page. And so that is the direction of F. Direction F is into the page. And because by Newton's second law, if we like apply a force on an object, it would have wherever the force is like, wherever the direction of the force is like acted upon the object, the acceleration should have the same direction. So then that means the direction of A is also into the page. Therefore, A is equal to the magnitude 7.3 times 10 to the 14 meters per second squared into the page. We have a magnitude and direction, which makes the A vector. So that is the acceleration, both the magnitude and direction.